Alright, for the first day of semester 2, we're going to still use some trig, but it is going to be a different type of trig. But first, let's recall what we did last year. If we were solving for right triangles, we used SOHCAHTOA to solve for these right triangles. So if we want to find lowercase b, c, and then angle b. So let's just go in the order it starts with. If we start with lowercase b. Here's our lowercase b, and I can see that with respect to the angle, that's the adjacent, and this is the opposite. So that would be TOA, tangent. So tangent of my angle, which is in degrees, and this is a calculator section, by the way, tangent of our angle equals opposite, which is 31.4, over adjacent, which is b. Okay, and then something that we talked about last semester when we were doing these types of problems is that if your variable is in the denominator, perhaps the fastest thing to do is just to switch these two things. So that means that b is equal to 31.4 over tangent 27. So we type that into our calculator using degree mode. So go ahead and type in 31.4 divided by tangent 27. And I get 61.626. So we use approximately sign, 61.626. All right, let's go ahead and if we wanted to solve for C, you could do that in a couple of ways. Now that we have what lowercase b is, we could go ahead and do Pythagorean theorem. If we want to practice our trig, we could say, well, with respect to my angle, C is hypotenuse and this is opposite. So I'll go ahead and do that. That's sine of our angle equals opposite over hypotenuse. So switch them again. And we get approximately 69.164. Okay, and then lastly, to solve for angle B, of course the easiest thing to do is angles of a triangle add up to 180, so if we go ahead and do that, we get 63. All right, in example 2, if PQR is a right triangle, so go ahead and draw your right triangle. And it tells us that Q is the right angle, and this is 147.6. So we'll just have to label one of these P and one of these R. We don't really know. Cross R is 72.15. And we're going to find what angle P is. So we're going to find this angle right here. If you didn't catch that, what I did when I labeled is across angle Q, so go across that, is lowercase q. Across angle R is lowercase r. So this would have been lowercase p. So across the side is the corresponding angle, or across the angle is the corresponding side. But anyways, in order to solve for angle P, so this angle right here, I say, well, with respect to my angle, I know what the adjacent is and what the hypotenuse is. So that's cosine. So cosine of my angle, and I'll go ahead and call it P, equals adjacent over hypotenuse. And so I can go ahead and inverse that. And I get cosine inverse 72.15 divided by 147.6. So 60.737. So it's approximately 60.737. So when in doubt, go ahead and round to the thousandth. It may say otherwise, but if it doesn't say, just to be safe, let's do the thousandth. All right, so this should all be fairly fairly old stuff that you understand and know. What we're doing today is actually the law of cosines. So the law of cosines, there are kind of 3 law of cosines, but they're really all the same. So these are the 3 laws of cosines. You have a squared equals b squared plus c squared minus 2bc cosine a. And then b squared equals a squared plus c squared minus 2ac cosine b. Or c squared equals a squared plus b squared minus 2ab cosine c. You do have to have these memorized, but it's not really as hard as it seems, because no matter what the letters are, whatever you have here, letter lowercase a, you're going to have cosine of capital in that same letter. Lowercase b, cosine capital B. Lowercase c, capital C. And then in between are your other 2 angles. Okay? So let's just do a really quick example if I gave you something else, just to practice what I mean when I say it's easy to memorize. So if I gave you PQR again. So let's do angle P. So we'd have P squared equals, so it's the other 2 letters, so Q squared plus R squared, and then a minus sign, 2, and then use those same 2 again, QR. And then this is the law of cosine, so cosine, and then we go back to the letter on the outside. It's kind of like a palindrome, if you know what that word means, where a palindrome is, if you read it left to right or right to left, it reads the same. So you've got the starting letter and the ending letter is the same. Okay, so it'll get easier to memorize it and after a while. So in the beginning, if you have to go back and forth, it's okay. Let's take a note really quick. What happens in the second equation if angle B is a right angle? So as you can see, I drew this triangle on your piece of paper. You have this triangle, and it looks like B is a right angle. If B is indeed a right angle, then in that second equation, you would have cosine of B is a right angle, 90. So what is cosine of 90 degrees? Well, cosine of 90 degrees is adjacent over hypotenuse, and the adjacent up here is 0. So cosine of 90 equals 0. So if I had b squared equals a squared plus c squared minus 2ac cosine of 90, if this is 0, then this whole thing goes away, and you end up just with Pythagorean theorem. So it's a derivation of Pythagorean theorem. It's just an extension of it because the law of cosines can be used for any triangle, not just right triangles. All right, so let's do some examples. All right, so let's find lowercase a. If I'm going to find lowercase a, let's go ahead and label our lowercase letters. So this is lowercase a, lowercase b, and lowercase c. And if I'm going to find lowercase a, then I'm going to have lowercase a squared equals, so let's practice the formula. So it's the other 2 letters, b squared plus c squared, then a minus sign, 2, and then use these letters again, bc, and then cosine of, so this was a, so we're going to do now capital A, because that's the angle. All right, so that's the formula. So let's fill in everything that we know. So I know lowercase b is 5. I know lowercase c is 7. So I know lowercase b and c. And I know capital A is 39. So I've got a squared equals 5 squared plus 7 squared minus 2, 5 times 7, and then cosine of 39. Okay, so there's no need to really type this in any fancy way. I'm just going to type all this in my calculator at the same time, exactly how I see it. So 5 squared plus 7 squared minus 2 times 5 times 7 times cosine 39. So I get a squared equals 19.599. Actually 7, so that would have been 19.6. It doesn't matter though, because I don't want you to clear your calculator yet. I want you to now take the square root. So when you type that into the calculator, I want you to use A and S. So square root symbol, and then second, and then use the negative symbol, and that puts in the last answer that you used. So 4.427. And this is not equal to, it's approximately 4.427. So we're using approximation because we don't have the exact answer. We had to use a rounded answer. That's all approximate means, is that we rounded approximately. A is now approximate to 4.427. All right, so let's draw a triangle again. ABC, capital A, capital B, capital C, and capital A is 51. And so this is lowercase a, lowercase b, lowercase c. And we're told lowercase b is 4 and lowercase c is 5. So this is really just like that example that you just did. So why don't y'all go ahead and do this on your own. So I'll pause it and do it, and then, so go ahead and pause the video. So I got A is approximately 3.978. Okay. Let's go to example 3. So in example 3, we have triangle XYZ. X, Y, Z, lowercase x is equal to 3, lowercase y is equal to 7, and lowercase z is equal to 9. And if we want to find angle Z, so whatever angle you're trying to find, or if you're given it, it doesn't matter, but since there's only one angle in the equation, it is the angle that tells you how you're going to end. So I'm going to end with the Z. Actually, I'm going to end with cosine Z, right? That means I'm going to begin with lowercase z squared. So z squared equals x squared plus y squared minus 2xy cosine z. All right, so lowercase z is 9. 9 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine of z, which I don't know actually. So this is a lot different of a problem because now my variable that I'm looking for is attached to a cosine. So how am I going to be able to do this? Well, if this is your variable, I'm going to have to get rid of this, and then since this is a multiplication thing right here, I'm actually going to have to divide that. All right, so if we are solving for z, which is right here, then algebraically I need to do this stuff, and then I will divide, and we'll see what happens. So I get 81. So I'll take this pretty slow right now, but you can see how it's going to get a lot easier as you get used to this. 3 squared is 9. Oops. 7 squared is 49. 2 times 3 is 6, times 7 is 42, and then cosine z. So right here, 9 plus 49 makes 58. So now I have 81 equals 58 minus 42 cosine z. Make sure you don't subtract that 42 from the 58 because this is like a variable. It's 42 cosine of z. It's not just 42. So you can't combine that right now. I can, however, subtract 58. So 81 from 58 is 23. So I get 23 equals negative 42 cosine z. Don't drop that negative sign. That's a common mistake right there. And then divide by negative 42. So we're almost done. So I get 23 over negative 42 equals cosine z. So we practiced this. This is why we did that warm-up. Just to kind of recall things. If we have z that's attached to a cosine, I need to take inverse cosine on both sides. And so that's how I get rid of that to get z all by itself. So z equals cosine inverse of 23 over negative 42. So if we type that into our calculator, we get 123.204. So angle z equals 123.204. All right, and let's do this last example. Triangle XYZ, so let's go ahead and draw that. XYZ. X is 3, Y is 7, and Z is 11. And it says to find all missing parts, round the sides to the thousandth and angles to the nearest whole degree. So we only have to do the angles. Let's just pick an angle to start with. Let's pick Y. So if I'm going to end with a Y, that means I'm going to start with a Y. Hopefully this equation is already getting easier for you to memorize. So I have Y squared equals X squared plus Z squared minus 2XZ cosine Y. So I know Y is 7, X is 3, Z is 11, cosine Y. So if you want to pause this, you can. Go ahead and try to do it yourself. I have 49. 9 plus 121. So I end up with cosine y equals 81 over 66 if you inverse cosine that. So everybody, if you do this, you actually end up getting an error on your calculator. It says domain. So this is no solution. I do want to talk about why this is no solution, rather than just saying it's no solution. It's no solution because of a kind of old geometry rule. And that old geometry rule is that if you know two smaller sides of a triangle, so in this case 3 and 7, the two smaller sides of the triangle added together have to be bigger than that third side. So if I try to draw this is to explain why, kind of trying to draw it to scale. If you have a side of 3 and you have a side of 7, imagine this triangle kind of flattening out. What is the biggest that this third side could be? So the biggest that could be, so if I draw it again, flat, even more flat, 3 and 7, you can see that this is not going to get any more than 10. So the fact that this is 11 says this actually, this picture that I've drawn, doesn't really ever make a triangle. It's impossible to draw the triangle whose sides are 3, 7, and 11. And so that's why it's no solution. So it's nice that our formula actually tells us that. The formula that always works will say, or kind of get us to the answer of this is an error, and then this is just me showing why that's an error.